All right, financial algebra. This lesson goes over so much review from algebra. So I want to start with the Pythagorean Theorem, which I'm sure you've seen before. A squared plus b squared equals c squared. Okay, I'm sure you've seen it, where the parts on the left represent the legs and c represents our hypotenuse. Okay, so we are going to be using that. Remember, this is for right triangles, and our hypotenuse is always across from our 90-degree angle, and then the other two sides would be our, they call them legs. Okay, so that we're going to be using that formula. Second, let's review that slope is represented by the letter M, and it represents rise over run. Now, rise refers to up, down, and run refers to left, right. So we're going to see that a lot in this section, talking about the slope, like of a ladder, or of stairs, or a ramp, or the roof on your home. So we're going to be using that. And then third is a review of SOHCAHTOA. So sine. This is S stands for sine, C is cosine, T is tangent. Okay, and then we use this to find missing. We use sine, cosine, and tangent to find the sides of a triangle. We use the inverse, sine inverse, cosine inverse, and tangent inverse to find angles. Okay, so that's a review from geometry, Pythagorean theorems, geometry, slope is algebra 1. And then finally, just some notation. So when you see a 1 apostrophe, that is the symbol for feet. Inches, there should be 2. And so like if you see 5 and then 6, this would be 5 feet 6 inches. Okay, that would be an example. So when you state your height, feet should have 1 little slash or apostrophe, and the 6 has like the parenthesis symbol. So that is a lot of information I'm writing down on here that we're going to use to do the following examples. So number 1. Ruth is setting up the locations of the corners of a deck that is going to be 10 feet. That's why there is only 1, right? That represents feet by 24 feet. To make sure that it's a perfect rectangle, she's going to check with the diagonals, that they have to be the same. So it says, what should the length of each diagonal be? There's technically 2. And they need to be identical. And they should be identical because if this is a perfect rectangle, then I know that the left width is 10 and the length up here is also 24. So to find the length of our diagonal, I'm going to go ahead and do the work down here. So part A, let's just say I'm looking for this diagonal. This corner right here should be a 90-degree angle. So this is 10, this is 24. I'm looking for my diagonals. If you want, we can make that D. Okay, so I'm going to use the Pythagorean Theorem. Now, the Pythagorean Theorem states that I'm going to keep my hypotenuse by itself and put the legs together. So 10 squared plus 24 squared. It doesn't matter what order you write that in. You can write 24 squared first. It's really up to you. And I get 676 equals d squared. So then you are going to take the square root. And I got that your diagonal equals 26. And in this case, it would be feet, right? So the answer to part A is 26 feet. And it should be the same for this diagonal, right? Because it's another 10 by 24 triangle. What angle does the diagonal make with the longer side of the deck? So here is, this is 10, this is 24, and we just found that this is 26. They're asking for this angle that is with the longer side of the deck. So they want to know what this angle is. And you can really use any trig function. But let's go back to what I wrote up above. I will use sine, cosine, tangent to find our sides. But if I'm looking for an angle, I'm going to use the inverse functions. So I'm actually going to use tangent inverse. And I'm going to label this is opposite. This side here is adjacent. That's why I'm using TOA, T, because I have opposite and adjacent. So 10 over 24. And that will equal my angle. So I'm going to go ahead and put that in my calculator. Second tan inverse of 10 divided by 24. And I get 22.6. And it says round to the nearest degree. So I got 22.62. So I'm going to round to the nearest degree. That would be 23 degrees. All right, now part C. What angle does it make with the shorter side? So I'm going to draw my rectangle again. I know this is 10. I know this is 24. So it wants to know the angle formed with the shorter side, right? 10 is the shorter side. So I'm now looking for this angle here. Okay, so according to this angle, the side across would be opposite and the leg touching is adjacent. So I'm still using tangent inverse, but this time it's 24 over 10. Right? I'm not using my hypotenuse. I'm just using the legs. So second tan inverse, 24 divided by 10. I got a angle of 67.4 degrees, and it said round to the nearest degree, so 67 degrees. Now that's one way to find it. An easier method would have been, we know this is 90, and we just found that this is 23 degrees, and all three angles in a triangle, I'm trying to use shorthand, in a triangle, add up to equal 180 degrees. So 180 minus the 23 minus the 90 is 67 degrees. So that is another way you could have found that. So moving on, notice how much review this is of other math classes. Jake is installing a staircase so his children can have access to a treehouse. So the rise, remember rise is up and down. So rise is 7 inches and the run is 10 inches. What is the slope? Well, remember slope equals rise over run. So in this case, it'd be 7 inches over 10. And that's it. Rise over run, which we just determined, was 7. And you can write inches or you can use the apostrophe. Totally up to you. Moving on. Number 3. Now, I like to draw pictures so that I get a feel for what I am, sorry, I'm trying to get this camera right, for what I am solving for. So this says that this golf driving range is installing a huge net. The poles to hold up the net are 50 feet high. So I drew myself a pole. They're telling me that this is 50 feet high. The contractor needs to run a wire from the top of the pole to the ground. And they call this a guy wire. Don't know why. And the wire is called the guy wire. So part A, if the guy wire runs from the top of the pole to a point on the ground 22 feet away from the base. So they're saying, they mentioned the ground, they're saying from the base all the way to this point is 22 feet. How long must the guy wire be? So I'm solving for this. You can make it whatever letter you would like. So I drew a picture so I know where my 90 degree is, right? Any pole, any telephone pole is not standing crooked or slanted. It should stand straight up, and then the ground is straight. So your 90 degrees should be between the pole and the ground, okay? So remember this right here is the pole, So I have, it doesn't matter what order you put your legs in, so 50 squared plus 22 feet squared equals our guy wire, or in this case, x squared. So I got 2,984 equals x squared. And then to solve, you would take the square root. So I got x equals 54.6. Now it said to round up to the next highest foot. So I'm going to make that 55 feet, right? The next highest would be 55 feet. What is the slope of the guy wire? Remember, slope equals rise. So how much did we go up or down? Over run. So my rise is 50, right? And over 22. And I would reduce that to be 25 over 11. Okay. Next one. Bill bought a set of car ramps so he could work under his car. He drives his car up the ramp, and then the wheel sits on top of the shaded region as shown below. So he's telling us if MA is a slope of 9 inches, represent what is the slope of the ramp. So they've told me this is 30. This is my run. They told me this here is 9 inches. So rise over run, right? 9 would be your rise, would be 9 over 30. And I'm going to reduce that. That would be 3 over 10. I reduced it by 3. If now they're asking a different question. So if MA, so that's this part right here, is 9 inches, and this is 30, what is the angle of elevation, angle R? So they want to know this angle here. So here's my 90 degrees. So I'm going to label my sides. If it's across from, we call it opposite. If it's touching, we call it adjacent. My hypotenuse is unknown. So I have opposite and adjacent. So when I write SOHCAHTOA, I'm looking for which one has an OA, and that would be tangent. Since I don't know what the angle is, it's tangent inverse of the opposite side over the adjacent side. So I'm going to enter that in my calculator, and I got 16.7, but it said round to the nearest degree. So I'm going to round that. The nearest one would be 17 degrees. But again, pictures help. All right, a couple more. So I believe we have 3 more. So number 5 is the picture of a house on a roof. And this represents the length of our roof. And we call this part here, and it's on both sides as you can see, we call that the pitch. So in this case, the pitch is going to be the same as our slope. Okay, so I'm going to go ahead and write that for you. The pitch is the same as the slope. Okay, so this is asking for what is the length of the roof. So they've told me, here's a 90-degree angle. I know that this is 18 and I know this is 30. So I'm solving for this piece here. So I have my legs are x squared plus 18 squared equals 30 squared. So this one is slightly different. I'm actually going to subtract, right? 30 squared minus 18 squared. So I got x squared equals 576. Take the square root, and I get x equals 24. Now, if this is 24, this is also 24. So 24 times 2, the length is 48 feet. Oh, it just wanted the run. Never mind. It's just 24. It wanted this part here. So 24 feet. What is the pitch? So I have a rise, right, this part here, of 18. And I have a run, we just found, of 24. So my slope or the pitch would be 8 rise over run, and that can be reduced to 3/4. All right, next, I had to draw a picture for this, so part C. He needs a ladder. So here is the height of the home. So according to the picture, the height is 28 feet. He needs to purchase a ladder. So this here on this side would be our ladder. Right, this is a 90-degree. You lean a ladder against the wall. If the recommended angle of elevation is 66 degrees, so from the ground up, how far must he place the foot of the ladder from the house? So he's looking for this distance here. So I'm actually going to use my trig functions because I only know one side and one angle. So I'm going to go ahead and label my sides. Across from the 90 degree would be hypotenuse. Across from the 66 degrees would be opposite, and x would be adjacent. Okay, so I am actually going to use tangent of 66 degrees, because I'm looking for a side, equals opposite over adjacent. Now I have an invisible 1 here, so I'm going to cross multiply. So x times the tangent of 66 degrees equals 28. I cross multiplied. I multiplied these and then those. Then in order to solve, I would have to divide by the tangent of 66 degrees. So x equals 28 divided by the tangent of 66, and I got 12.5 feet. And I will show you. So 28 divided by the tangent of 66, and you close it out, and that's where I got the 12.46, or it said to round to the nearest tenth. So this is part C. So that's how far the bottom of the ladder should be from the wall. Now, for part D, it's asking how long the ladder should be. So this is 66, this is 28. We just found that this is 12.5. Now they want how long the ladder should be. So I'm going to make L. So how tall of a ladder. So you can do quite a few things here. You could do a Pythagorean Theorem. You could use SOHCAHTOA. It's totally up to you. But I know that this is the hypotenuse. So 12.5 squared plus 28 squared will equal L squared. So if I calculate the left, I got 900, I got 940.25 equals L squared, and then I took the square root, and the square root of 940.25, I got L equals 30.66, but it said to round to the next highest foot, so I need a 31-foot ladder. All right, so next one. Number 6. Mark has a tree in his backyard. He wants to make sure it will not fall on his neighbor's house if there is a bad storm. The tree is 49 feet from his neighbor's house. From a point on the ground, 35 feet from the tree, the angle of elevation to the top of the tree is 50 degrees, and it said that this point is 35 feet. And it wants to know the height of the tree. So I'm going to label my sides. The tree and the ground should make my 90 degree. So according to what I have the opposite over this touching is adjacent. So I'm going to take the tangent of 50 degrees equals the opposite over my adjacent side. And then I'm going to cross multiply. So 1 times h equals 35 times the tangent of 50 degrees. So 35 times the tangent of 50 degrees. I got 41.7. And it said to round to the nearest foot, so 42 feet. Last one. All right, so this has to do with a ramp for those in wheelchairs or have disabilities. And there's a standard elevation these ramps can be, right? If you are wheeling yourself up in a wheelchair, you can't have this crazy steep hill. It would be terrible. So it has to be a specific slope or specific height. And so this goes over that handicap ramps for wheelchairs have to have a slope of 1/12 or less. A diagram of the ramp is shown. So part A says convert 22 feet into inches. So 22 feet times, there are 12 inches per 1 foot, so the feet cancel, and 22 times 12, I got a 264 inches. What in inches is the maximum height that ramp can be? Well, I can only have a slope of 1/12, and so this would be my rise, right? This is how far up, and this would be my run. So BC over 264 inches. So I'm going to cross multiply to solve. So 264 would equal 12 times BC. If I divide by 12, BC can be a maximum of 22 inches. Don't confuse that with 22 feet. If BC has a length of 9 inches, and this is 264 inches, what is the slope? Well, rise would be 9 over 264, and those can be reduced by 3. So 264 divided by 3 gives me 88. And so is that 1 divided by 12 is 0.083. 9 divided by 264 is less than that. So that would be okay. If BC has a length of 10 inches, what is the angle of elevation? And we know this is 264 inches. So they want to know this angle right here. So I have opposite and adjacent. So tan inverse, because I don't know the angle, of 10 over 264 will tell us our angle in degrees. So the tangent inverse of 10 divided by 264, I got 2.169. Said round to the nearest tenth, so 2.2 degrees is this angle right here. And that should cover what you see in the homework. So print these notes, open them up while you're doing your homework if that helps.